All right, welcome back to Anatomy and Physiology, Day 78, Part 2. Okay, so we're going to continue on with the 6 essential parts of digestion happening in the body. So we've got Part 4, which is food breakdown. This is the actual digestion part that we're dealing with. So here we've got different enzymes in the body that break down big molecules into their essential kind of building block chunks there. Each major food groups use different enzymes to break these food down, these polymers, these big molecules, into their smaller, simpler products. So for example, we can see carbohydrates like sugars and starches and things break down into what we call monosaccharides. Those are simple sugars. Proteins, which would be meat and beans, eggs, things like that, have got a lot of protein. They break down into amino acids. And then fats are going to break down. Fats would be like oils and like butter, things like that. They're going to break down into fatty acids and glycerol. Okay, so I'm just kind of visually we're looking at digestion here. So this is really kind of starting a little bit in the stomach, but mostly into the small intestine. And if we kind of continue down, you can see that that's really kind of everything that's happening through the small intestine is that digestion part of it. So again, stomach, we're kind of breaking things down in there, all the way through the small intestine there. Okay. So just kind of some background a little bit. So enzymes are what we call biological catalysts. They speed up reactions. The enzyme, kind of a key feature of it is it reverts to a usable form after completing the reaction. So if we look at kind of our image here, this is our enzyme, this is our catalyst that we've got going on. So we've got something coming in, substrate, which would be kind of the initial thing that we have happening, and then the product is kind of whatever its finished thing is at the very end there. So it's substrate coming in, they join together and make kind of a finished product at the very end there. So again, to kind of get some of this digestion demonstrated. So inside, this is looking at the mechanical actions of the stomach that help increase the chemical digestion. So we've got the stomach doing peristalsis, propulsion, kind of moving things through it. It does what they call grinding. So this is vigorous peristalsis. Pyloric end, which is down here, acts as a pump that delivers just kind of small amounts of material through the stomach into the large intestine. It's worth noting this small amount of material. We had the bolus of food coming in from above, but once we kind of mix it up and kind of mash it around and chemically break it down, the material that leaves the stomach into the small intestine is now called chyme, and it gets into that first part of the small intestine, which is the duodenum. And then there's what's called retropulsion. This is kind of reverse peristalsis, closes the pyloric sphincter, and kind of pushes stuff back around, recycles it, and kind of grinds it back up again before it kind of goes back forward. Okay, so looking at some of the specific types of things that we see, specific enzymes that we see happening and kind of where they occur. We'll start on carbohydrates first. So we're going to look at the breakdown of carbohydrates. So in our mouth, we have amylase, and our pancreas, we also produce amylase. So it's kind of, they happen down there. So salivary glands and pancreas release amylase. And they really kind of the major drivers of breaking starches and disaccharides into these other sorts of things. And eventually we end up with these fructose, maltose, lactose. Those are kind of the simple sugars that we kind of end up with as a result. But again, amylase is kind of the major one. There are a number of things that happen in the small intestine, these brush border enzymes that break things down even further. But you can see just basically big carbohydrate molecules into small carbohydrate molecules. All right, and then it talks about these monosaccharides, right? Enter the capillaries, the blood vessels, the villi, and transported to the liver, right? So that's kind of our key note there. Okay, so next one we want to look at is proteins. So at this point, we've kind of left the mouth and esophagus. We no longer don't really produce anything in our mouth that helps break down proteins. But when we get to the stomach, we do start to produce a couple of things. So pepsin, in the presence of hydrochloric acid, helps break it down. And then the big one is when we get into the small intestine, the pancreas releases something called trypsin. And trypsin is kind of the major one that we want to focus on. So note trypsin. It's a major one that we want to focus on as far as breaking down big polypeptides into smaller polypeptides, eventually into individual amino acids. And then we can use those to rebuild other proteins in our body. And again, more brush border enzymes to kind of come into play. And again, they're picked up by the capillaries and the villi and transported to the liver. But the major one we're focusing on here is trypsin. All right, and then fats or lipids. So these are, again, kind of starting in the stomach, a little bit into the small intestine is kind of mostly where this happens. So emulsification by bile salts from the liver. So the liver produces bile, stores it in the gallbladder, which is kind of underneath there, and then it's going to squirt that and join some stuff from the pancreas at the very top of the small intestine, the duodenum, and then it's going to start breaking that down, emulsifying the fats is what we call it. And you can kind of see the glycerol and short chain fatty acids, right? So again, capillary bloods in the villi transported to the liver via the hepatic portal vein there. All right, so just kind of another view of what we're looking at, so you can see, well, what organ are we dealing with? Salivary gland, stomach, small intestine, pancreas, and liver. What are the enzymes produced? I tried to color code it so the carbohydrates were kind of the green, proteins were kind of red, and then digestive lipids are kind of this yellowy color. And then as per Lab 25, kind of says note major enzymes and look at the specific things. So here you can see kind of the major enzymes, kind of where they come from and what they do. But in Lab 25, it specifically notes trypsin, which is released by the pancreas, protein, pancreas, here we go, to digest proteins. So trypsin right here, released by the pancreas to digest proteins. And then down below, we've got bile released by the liver, or produced in the liver, and then released, stored in the gallbladder, eventually released there to break down lipids and fats. And you can just kind of make note that amylase is kind of the other big player that we're going to be dealing with. All right. And then finally, we're going to move into actually, we got two more. So absorption. This is the big thing. We've been breaking things down, breaking things down, breaking things down, breaking things down. So finally, we want to absorb stuff. This is the end product of digestion, is to get us to things that can be absorbed, that are small enough. So food must enter what we call the mucosal cells and then move into the blood or lymph capillaries. And this is mostly along the small intestine. There is some stuff that happens in the large intestine. It's important to note there's no digestive enzymes that are produced in the large intestine. And we do have kind of a store of bacteria that we sort of farm in our large intestine. And they feed off all the stuff that we haven't absorbed up to that point. So these resident bacteria digesting the remaining nutrients, and they produce some things that are important for us, like vitamin K, which is helpful in blood clotting, and vitamin B. Also, we start to absorb a lot of water. So we've been adding fluid to that chyme, and then we absorb that water, absorb any vitamins and ions. And again, water's there. The remaining, everything that's left over at that point becomes what we call feces, and eventually it's going to be eliminated. And so again, you can see small intestine, kind of we finish with the digestion. Large intestine here, we're going to be, it's got mainly water, so mostly water is kind of thing that we pull out. But we also pull out those other things, vitamin K and vitamin B and so on. And again, what's left over is the feces there. And that leads us to the last step, which is defecation. And so this is the elimination of the indigestible substances from the gastrointestinal tract in the form of feces, and that contains a bunch of stuff. It's the undigested food residues, so any fiber or anything like that we're eating. There can be some mucus. So, usually a significant portion of fecal matter is bacteria. It's the dead or worn out bacteria that we kind of store in our large intestine. Some water, but not a lot. Some water. And then the way this works is that as the presence of feces in the rectum builds up, it causes what's called a defecation reflex. So that internal anal sphincter feels that pressure and it starts to relax. And then we've got the external anal sphincter, which kind of wraps around the internal anal sphincter. And then we can say, okay, now is the time or now is not the time to defecate. And so defecation occurs with that relaxation of the voluntary or external anal sphincter there. Okay, and again, we're kind of down your feces to anus to defecation at the very end there. So just kind of overview, again, you can look at ingestion, repulsion, mechanical breakdown, digestion, absorption, defecation. And that kind of tells the main story of what we're looking at across the lab today. And then next class, we'll get together and we'll look at the urinary system. So we'll deal with that part of it. And that concludes today. All right, thank you very much.